if ax squared plus bx plus c factors, then you could write as you could write it this way. I'm using Z1 and Z2 as the two factors. I'll do an example in a minute, okay? And then you can solve equals 0, okay? And the solutions have to be x equals Z1 and x equals Z2. Because, of course, if x equals Z1, what's x minus Z1? Huh? I'm sorry, I didn't hear you. Okay.
You said of what?
If x equals Z1, plug in Z1 for x, what do you get?
0.
Get 0 because Z1 minus Z1 is 0, right?
Yeah.
Okay? Plug in Z2, what do you get?
0.
For the reason that Z2 minus Z2 is 0. So when whatever these two terms are, if this one's 0, then you get 0, right?
Mm-hmm.
And whatever the other terms are, if this term is 0, everything multiplies out to 0. If you multiply a bunch of numbers and one of them's 0, then the product is 0, right?
Yeah.
Now we want to get that firmly in our mind because it's really important, okay? So for example, now we've seen examples of applying the quadratic formula. We've done this, okay? We haven't done factoring, but we're getting to the point where we need to. Okay, so an example of this. X squared plus 5x plus 6 equals 0. In other words, we're trying to find the zeros of the function y equals x squared plus 5x plus 6, right? Well, that factors, it's easy to factor. You know the distributive law well enough to at least verify that this factors into this, right? You can verify the distributive law for this. Now, factoring's a skill you're supposed to have when you come in here. So we'll do some work with that in here, the MCR class, okay? Because we're going to need that next week. Okay, but anyhow, you get this, right? The only way this is going to give you 0 is if either this equals 0 or this equals 0. Right? Okay, well, it follows then. Okay, now let's be sure we understand the logic of this. Why do I have an or here?
Because it's two.
There's two different ones.
Because it can't be both, right? If x plus 3 is 0, then x plus 2 isn't.
Yeah.
If x plus 2 is 0, then x plus 3 isn't. But either way, if either of these is true, then this is 0, right? So it's this or this. I can't say this and this, right? Although my solutions are -3 and -2, right? My zeros are at both of these points. Okay? So the solution of the equation is -3 or -2. A solution is this or this. So my solutions are this and this. little
So if you were
distinction
to
between.
figure out which one it is, do you just plug in one of them to X and
Well,
whichever
they're
one
both
equals
zero.
They're both zero.
Yeah, which means that the graph passes through the x-axis at -3, 2, and -3, 0, and -2, 0. Those are the zeros, okay? So the graph, here's my x-axis, here's -3, and here's -2. So whatever my value of A, the graph would pass through those points. And where's the axis of symmetry?
-1.
Got to be between here. Axis of symmetry is here, right?
Oh,
-2.5.
2.5, my fault.
Okay? So we get the axis of symmetry. Okay?
Yeah, I was,
So the other thing that we can say from this is it's halfway between x equals z1 and x equals z2. Otherwise, you wouldn't have symmetry.
Yep.
Okay?